We now know one way to solve an equation algebraically, with the substitution method. Next, we're going to look at something called the linear combination method, which is also sometimes referred to as the elimination method. Just like with the last video, the steps are going to be somewhat less meaningful when you're copying them into your notes at this point, and then they'll make a little bit more sense once you see an example. But your first step in the linear combination method is to write both equations of the system in standard form. So make them both look like ax plus by equals c. Then you want to manipulate the two equations so that you can end up with one variable, either the x or the y, and it ends up having opposite coefficients. So maybe, for example, the first equation has a 3x and the second equation has a negative 3x. Or maybe the first equation has a negative 7y and the second equation has a positive 7y. You will accomplish that by multiplying one or both of the equations by a coefficient. After that, you will add the columns of the problem, and that will eliminate one of the variables and allow you to solve for the other. And then once you know what one variable is, you can use substitution to solve for the remaining variable. So let's look at an example to make this more clear for you. So our first equation is x minus y equals negative 4. Our second equation is x plus 2y equals 5. Step 1 was to write both of these equations in standard form. That's done for us in this case. They're both in standard form already. Step 2 was to multiply one or both equations by some constant so that we end up with opposite coefficients in front of one of the variable. Now we're actually pretty close to this right now with the x's. They're both a 1x. We just need one of them to be a negative 1x. So it doesn't really matter which equation you pick. Pick one of the two equations. And the way we would change a sign is to multiply by negative 1. So I'm going to take the top equation and I'm going to multiply both sides by negative 1. And then that gives me the opposite of x plus y equals 4. The second equation I'm going to leave the same, x plus 2y equals 5. So in this case, I only multiplied one of the equations by a constant. The next step was to add the columns to eliminate one of the variables. So when I do the opposite of x plus x, that equals 0. When I do y plus 2y, that equals 3y. When I do 4 plus 5, that equals 9. And then this equation I can solve easily by combining my like terms and then also using inverse operations. The last step of the linear combination method is to substitute into either of the original problems the variable that you just figured out. So I'm going to use the first equation, the x minus y equals negative 4, and I'm going to plug in the y equals 3. Use inverse operations to solve this by adding 3 to both sides, and now I know that x is negative 1. So my final solution to this equation is the ordered pair x comma y, or negative 1 comma 3. Remember that it's going to be a good idea to check all of your solutions. So we're going to go back to the original problem and plug in the negative 1 for x and the 3 for y, and make sure that we get true statements for both equations. So we see here that the first equation works, and then plugging into the second equation, and that one also works out. So I know that my answer is correct.